In this lecture, we're going to dig a little bit deeper into the concept of providers. And by the end of this lecture, you're going to know how we can configure injectors with providers in Angular. And you're going to know about the 4 different types of dependencies we can configure a provider to provide. So as mentioned in the previous lecture, we can configure injectors with providers, and a provider links a token to a dependency. But so far we seem to be configuring our injector with just a list of classes. So for example, in the code you've got in front of you, we just seem to be configuring our injector by providing, well, a list of class names. And that's because what this is in fact a shortcut for the long form way of writing a provider. So normally we would provide an array of objects. The real configuration for a provider is an object which describes a token and configuration for how to create the associated dependency. The provide property is the token and can either be a type, a string, or an instance of something called an opaque token. And the other properties of the provider configuration object depend on the kind of dependency we are configuring. And since right now we are configuring classes, in this instance we use the useClass property. But if all we're doing is providing a class with the token being the name of the class, we can just shortcut this to just the class here. Going back to our long form example, this is an excellent example of how we can use the DI framework to architect our application for ease of reuse, ease of testing, and less brittle code. So if we wanted to reuse our application and move from using Mandrill to SendGrid without using DI, we would have had to search through all of the code for where we've requested Mandrill service and replace it with SendGrid service. So we would search our code for every time we are requesting the token Mandrill service, and we would have to replace it with SendGrid service. But a better solution is to configure the DI framework to return either Mandrill service or SendGrid service depending on the context or the configuration. So one thing we can do is we can actually provide or change the name of the token to the string email service, and then this provider still returns an instance of Mandrill service, but just via the token email service, which is a string. So now if we run this, let me just get the console up. You can see in the console we're getting an instance of the Mandrill service printed out. But if we wanted to switch to using the SendGrid service, we can easily do that throughout our application just by changing one line of code. In our provider here, instead of configuring it to useClass Mandrill service, I just change it to configure to useClass SendGrid service. And then because in the rest of our application, we're just using the token email service, we don't need to change any other code. And everywhere we're requesting the email service, we'll now return an instance of the SendGrid service. Like so, if you look in the console, we're now returning an instance of the SendGrid service. So this makes our code a lot more flexible. It makes it a lot easier to reuse different services without changing the entirety of our application, without having such tight coupling between the token name and the dependency that gets returned. So far we've only seen how we can configure a provider to provide classes. However, there are 4 different types of dependencies providers can provide in Angular. Now we've covered the class method quite a lot already. We can either provide just the class itself as the provider, or we can provide a full provider configuration with the useClass property. But we can also make 2 tokens map to the same thing via something called an alias. So let me add another class called generic email service. And the first provider is just a normal one. I'm just going to provide the token generic email service, and I'm going to use the class generic email service. But let's say in the past we used to use something called a mandrill service. Wherever we were requesting mandrill service, we now want to use an instance of the generic email service instead, whatever the generic email service points to. So to do that, we can use, instead of use class, we can say use existing generic email service. So now whenever we request a token for mandrill service, it will use the configuration for the generic email service to resolve as a dependency. And we can do the same again with the SendGrid service as well. So now let's just see what this actually returns. And then let's see if it's returning us the same instances as well. So now if I run this, so now we've covered use class and use existing. We can also provide just a simple value with a provider. Now I've added another provider, one which provides a string API key as the token, and I've configured it to just return a value, an individual value, which in this case is just a string. So I'm providing this with an API key, and this is how I would configure an Angular application to store. This is how I would store my API keys in my Angular application so I can use them. So now if I run the application, all this does is it prints out the API key that gets returned. Now with value, we can also actually just return an object as well. So let's say use value instead of just a string. I'm going to pass in an object like so. And this object has an API key and an API secret. And I might change the provider token to just config. So I might just store the configuration for my entire application in an object that I provide to the dependency injection framework. And now if I request an instance of the config token, and if I print that out, we can see it's just going to return the actual object itself. But kind of using the injector with use value, I'm providing an object kind of has a problem. Now typically when we do this, we usually expect the object that we're passing around to be read-only. But the problem with passing around objects is that they can be edited. So now some part of my code grabs an instance to the configuration. I then change this somehow. And now when I request the instance again from the injector, let me just see what gets printed out. So you can see now the API key has been changed to foo. So some part of our code somewhere has updated this configuration. And configuration we typically don't ever really expect to change. We expect this to be read-only. We expect this to be a constant. Now what config points to can't be changed. We've configured that in the DI framework, but the properties of config can be changed. So when passing in an object that you intend to be immutable, and by immutable I mean unchanging over time, Then we use the object.freeze method to stop client code from being able to change the configuration object during the lifecycle of the application. So in use freeze, instead of just providing an object literal, we actually pass in object.freeze, and then to object.freeze we pass in the configuration object. So now if we rerun the application, we can see that now we actually get an error. We get the error cannot assign to read-only property API key of the objects. That's been caused by the line here. So just really a quick note, if you're actually intending to use the useValue dependency mechanism to pass around configuration, just remember to use the object.freeze method to freeze the property so some other part of the code can't change it by accident. We can also configure a provider to call a function every time a token is requested, leaving it to the provider to figure out what to return. So we call this the useFactory method. Let me delete all my providers here. In fact, let's keep one. I want to provide email service, the string as token, and then I'm going to configure my provider with a useFactory property. And the useFactory property is actually a function which the injector will call. Now, perhaps I have perhaps in development I want to use the SendGrid service, and in production I want to use the mandrill service. So outside of here somewhere I might have a constant called isProd. Perhaps I'm going to set that to true. And if isProd is true, I'll return an instance of mandrill service, else I'll return an instance of SendGrid service. But really, we can make this just do whatever we want. So now if I run this, you can see in the console we're now printing out an instance of mandrill service because isProd is equal to true. But just like other providers, the result of the calling useFactory is also cached. So even though we're using a factory and creating an instance with new ourselves, calling the injector multiple times, again will still return the same instance of mandrill service that was created with the first call. So if I call this twice, and then I compare the two instances that are returned, they are both exactly the same instance. So even though we are calling the function, we are creating the function ourselves that returns the instance, the result of this function is cached, and calling the same injector twice with the same token will return the same instance of a dependency. So to summarize, we can configure providers to return 4 different kinds of dependencies: classes, values, aliases, and through factory functions. And in the next lecture, we're going to look at the different ways we can define tokens in the dependency injection framework.